Uh, Anybody unmute yourself and tell me, are you able to see the screen? And,
Yes, yes, sir.
uh, okay. Good morning, everybody. Last class we discussed about the measurement of force and torque. In the measurement of force, the good example is analytical balance. And again, the force measurement can be classified into two types. One is direct comparison, other one is indirect comparison. In this way or in the other way also, you can explain this direct measurement and indirect measurement. Direct measurement is unknown magnitude is compared with the known standard magnitude. So almost all of you seen the dead weights of 100 grams, 200 grams, 500 grams, and 1 kg like that. So usually that's used in vegetable shop and grocery shop. Next, in indirect comparison, this is done by using calibrated device. Here you have three, two or more translations. Example, electronic weighing machine. Here, the resistance is converted into analogous signal. Analogous signal is converted into voltage signal. Again, that voltage signal is converted into analog digital form. From the digital display, you can measure the weight of the unknown magnitude you have placed on the platform. So these two are very, very important for mechanical engineers. The direct comparison and indirect comparison are very, very important. If you go to any company or any competitive examination, there will be 10% of questions are coming from measurement. So usually the questions will be like this. The classification of force measurement. So they may ask you the explanation or only objective type of question. Next, come to the point. All of you seen the vegetable market or vegetable shop or the grocery shop, there will be a weighing machine. In that, there will be two pans are there, left one and right one. Both are connected by a beam, and the beam is supported in the center with the triangular sharp edge, which makes the beam to oscillate left and right side and up and down. So from this, you can bring the symmetry of the beam so that the weight of the unknown magnitude and the standard known magnitude are both are same. That is nothing but when the needle reaches the zero, that indicates the weight of the unknown magnitude. That is the zero. Don't consider that is zero. That is the exact weight of the unknown magnitude you have placed on the right side. So that is the principle of operation of analytical balance. Analytical balance. Next, come to the point of very, very important, and you have this time in the examination, that is a multiple lever system or platform scale. Multiple lever system or platform scale. 100% guarantee. This time you have this question in the examination. So what are the things present here? Say all of you observe here. This is the beam which oscillates up and down and bring the into symmetry. Say the word symmetry, that is nothing but the beam should come to the exactly horizontal position. That is meaning of this symmetry is exactly 180 degrees. That is exactly horizontal condition. There will be a provision that the beam oscillates up and down. When the beam comes to the standstill condition on horizontal position, that is the measurement. So here, the one end of the beam, there will be a adjustable counterpoise. From this, you bring the beam to null balance. That is the zero reading, null balance. The one end null balance, and the one end of the beam is connected to the triangular sharp edge with the tension bar, and the other end there will be a counterpoise weight. Here you have to keep the poise weights provided by the manufacturer in terms of 10 kgs or 20 kgs or 50 kgs. Suppose if you want to measure 45 kgs, you have to keep two numbers of poise weights 20 into 2, and you have to move the moving counterpoise weight to read the fifth graduation that indicates the 45 kg. So like that, you have to measure the unknown magnitude, and the tension bar is connected to the lever by using triangular sharp edge. Other end is supported, and this end oscillates up and down. And on this, there will be one more lever which is hinged at one point. Other end is free. On that, there will be a platform. When you keep the unknown magnitude on the platform, remember anywhere on the platform, that is, see in the dotted line here, you can observe here W1 and W2. W1 plus W by 2 will give you the weight W. That is nothing but if you keep the unknown magnitude anywhere on the platform, that makes no difference in the result. That makes no difference in the result. That's very, very important. So the multiple lever system or platform scale. Then, so almost all of you onto the wholesale provision shop or the in mandi. So we call it as a APMC. So there also they are using the multiple lever system or platform scale for measuring higher weights. Next, come to the point. Say in our basic material testing lab, we have universal testing machine. So in that machine, you can load the specimen up to 50 ton, 100 ton or 500 ton is possible. The loading is completely hydraulic. The loading is completely hydraulic. Say, so after continuously using 5 years or 10 years or 15 years, to there may be little problem in the result. That is, you have error in the measurement. That you have to rectify, remove, and avoid the developing of error in the measurement. So for that, the instrument is available is proving ring. It is made of aluminum casting. All of you observe here, this is the aluminum casting of rectangular cross section, and you have a two projections. So these projections are necessary for fixing the proving ring in the upper jaw and lower jaw of the universal testing machine. See that the first adjust the universal testing machine to null balance. Null balance means zero reading. Then as you apply the load on the specimen in the same way, apply the load on the proving ring in intervals. That may be 100 kgs, 200 kgs or 500 kgs or 1000 kgs at a time, or 1 ton, 2 ton, like that. See that the thread, that's the reed, it is connected to the upper portion of the proving ring, which oscillates left and right, which oscillates left and right. Note down the reading of the weight which is connected to the reading. Suppose the weight is coincides with the 0, then there is no error in the measurement of anything using universal testing machine. See, all of you observe here. If the read coincides with the third or fourth division of the micrometer, then reverse the load in the opposite direction so that the read moves left side or right side and coincides with the previous reading, and there is no error. If there will be error in the measurement, the read coincides with any graduation in the left side or right side. That you have to adjust by adjusting the lever provided in the universal testing machine, that is the hydraulic loading. So a proving ring used for calibration of high or larger weighing machines. Larger weighing machines. This is very, very important for mechanical engineers because you may have the question in the competitive examination, how do you calibrate the universal testing machine? This is very, very important. Next, come to the point, the torque measurement. The torque, so all of you seen in the advertisement or in the new TV or in the paper, usually in the car advertisement, that produces 150 newtons meter or torque at 4,500 RPM of the engine. What is the meaning of that? That is nothing but the mechanical power developed by the engine. Remember, torque is can be defined as mechanical power or the energy developed by the machine or motor or compressor or pump. That is the engine or the pump or compressor or the turbine, how much torque it produces. That is very, very important. In turn, you can understand that is mechanical power. Remember, that is mechanical power developed by the engine. How much torque developed by the engine? How do you measure? Say for that, the instrument is available that is called dynamometer. The torque measuring instrument is called dynamometer. Many competitive examinations, you have a question, the torque measuring instrument. So you have four answers. That is, the answer is dynamometer. Dynamometer. Then you have a relationship torque T equal to F into R. F is the force developed by the engine or pump or compressor, and the R is the radius of the reaction or F into radial distance. You can also consider F into radial distance or R is radius of the reaction arm. T equal to F into R. This is very, very important. T, torque T equal to F into R. F is in force, that's in kg per millimeter square, and radius is in millimeter or in centimeter. That is T equal to kg force or T equal to Newton meter. And also you may have the question, how do you classify the dynamometer? The dynamometer is used for measuring the torque of the engine. That's classified into three types. One is absorption dynamometer and driving dynamometer and transmission dynamometer. Remember, in your lifetime, there will be three types of dynamometers are available: absorption, driving, and transmission dynamometers. First, to consider absorption. The name itself indicates absorption, which absorbs the energy developed by the engine or by the turbine or the compressor, which dynamometer absorbs and gives the result, the torque developed by the machine. That is energy which absorbs the energy and gives the result. That's in kg meter or Newton meter. Next, come to the point of driving. So that is nothing but which drives the another motor or the compressor or the turbine. From that, you can measure the torque of the turbine or compressor driving, which drives the another machine. From that, you can measure the torque. Next, come to the point transmission. Say one place to the other place. How do you measure? With the coupling using the torque developed by the machine, which is transferred to the another machine, for example, induction motor. From that motor, you can calculate the torque developed by the engine or developed by the turbine or developed by the any machine tool that can be measured in the other machine, maybe induction motor or the electrical loading or hydraulic loading. That is transmission dynamometer. Next, come to the point, very, very important. So all of you seen the brake drum and the brake mechanism in the two-wheeler or in the four-wheeler, how do you apply the brake? If you press the brake lever, what will happen? The brake pad along with the shoe enlarges. Then the friction between the wheel and the brake shoe, which reduces the speed of the wheel, in turn, the speed of the engine, which come to the standstill condition. So in the same way, instead of using composite material brake pad, here they use the wooden pieces or wooden eyelets. So which presses the shaft and bring the engine or bring the motor to the standstill condition. From this, you can measure the torque. See, all of you observe here. This is the Prony or mechanical dynamometer or absorption dynamometer. See, the name itself indicates absorption, which absorbs the energy developed by the engine or motor and connected to the platform scale. From this, you can measure the force. You can measure the force. You can convert that force into torque. That is T equal to F into R. Force can be measured through the platform scale, and you know the distance R, F equal to T into R. This is the experiment you have to conduct in the mechanical laboratory in fifth semester. So we have electrical loading system and mechanical dynamometer. That is also called as Prony brake or absorption dynamometer. The experiment is very simple. Conduct the experiment at one-fourth speed of the engine, half of the speed of the engine, three-fourth speed of the engine, and full speed of the engine. You conduct the experiment in mechanical laboratory. This is the absorption or mechanical or Prony brake used for measuring the torque developed by the motor or engine. Let's come to the point. Hydraulic dynamometer. Hydraulic. The name itself indicates hydraulic means water. Hydraulic means water. Almost all of you seen the flywheel. Say in the sugarcane juice making machine, in the left side, there will be a big wheel is there, which is rotating in the clockwise or anti-clockwise direction according to the requirement of the juice vendor. So that type of flywheel used in the sugarcane juice making machine, imagine the size of the hydraulic dynamometer flywheel is 1 meter or usually 1.5 meter or 2 meters flywheel. 2 meters flywheel, which is immersed in the water. Water is placed inside the casing. The casing is made of aluminum casting or cast iron casting. All of you observe here. This is the flywheel and supported with the bearings in both the sides. All of you observe here. This is the standard designation for showing the bearing on left side and right side, and the center of the shaft there will be a very big flywheel which is placed inside a water tank. Water tank. In this experiment, see first what are the things present here in hydraulic dynamometer. First consider inlet water and the shaft which is connected to engine or compressor or the turbine, and this shaft contains the flywheel of diameter 1 meter or 1.5 meter or 2 meters, which revolves inside the casing which contains the water. This is the inlet water. This is the inlet of water and this is the outlet of water, and the shaft is supported on 4 bearings, left side and right side. And this hydraulic dynamometer is also called as water brake. Water brake. Say first, before starting the machine, that's the dynamometer, see that the loading, maybe the speed of the shaft. You can measure the RPM of the shaft by using tachometer. So you can see the tachometer in the engine slab used for measuring the speed of the shaft by using tachometer. So then fill the tank with the 1/4 capacity of the tank and run the turbine or run the motor and note down the speed of the shaft. That's the first reading. Next, fill the casing with the the half of the container of the casing. Then run the turbine and note down the speed. When the casing or the housing filled with of its capacity with water, then fill the container with the 3/4 of water and note down the speed of the shaft by using tachometer. And again note down the full capacity of the casing of or housing of the hydraulic dynamometer and note down the speed. So you have the equation, substitute the values of the speed and RPM and the position of the water in the casing, and you know the radius of the radial arm. Substitute that in the equation. All of you know that the equation BHP equal to 2 pi into F into R, 33,000 RPM. You know that T equal to F into R. The force developed by the dynamometer and the radius of the reaction RM. From this, you can calculate the torque. So you can use the RPM of the engine, RPM of the shaft, which is connected to the turbine or which is connected to the motor. So this is the relationship. You can use it for calculation of torque in hydraulic dynamometer. Hydraulic dynamometer. Hydraulic dynamometer. 1 second. I will continue. I'll see that you have transmission dynamometer in the examination or not. Just I kept the syllabus copy. You have only two in the examination, that is the mechanical dynamometer and hydraulic dynamometer, and just to understand the transmission dynamometer. So here you have strain gauges are fixed to the coupling, and this is the beam, and this is the input shaft and output shaft. Here you have to measure the speed of the shaft. This input shaft is connected to engine or turbine or any device which produces the torque, and measure the speed of the shaft in the other end. The name transmission dynamometer that indicates the transmission of power, transmission of mechanical energy developed by the engine from one place to the other place. This is the input shaft and this is the output shaft. In the output shaft, you measure the speed of the shaft, RPM of the shaft by using tachometer. This is the transmission dynamometer. This is transmission dynamometer. Please, all of you, write down the question. Write down the question. This time, 100% guarantee this question in the examination. Please write down the question. Explain briefly. Explain briefly with the neat sketch. Explain briefly with neat sketch. Absorption. or or Prony break. Prony break. Type of dynamometer. Dynamometer. Put a question mark. List the applications. List the application. Next, write down. Explain briefly with neat sketch. With neat sketch. Hydraulic dynamometer. Put a question mark. List the applications and limitations. Next, you write down the question. Explain briefly with neat sketch. Transmission dynamometer. Transmission dynamometer. Put a question mark. List the applications. List applications and limitations. This is the last portion in force measurement, force and torque measurement. This is the last portion in force and torque measurement. Now, all of you, please write down your name and USN in the chat box. Now, I stop at this stage. Please, all of you, unmute yourself and write your name and USN in the chat box. All of you unmute yourself. Unmute yourself and answer roll call. Pawan MC. Pawan MC. Prithvi M.
Present, sir.
Rahul N.
Yes, sir.
MC. Shashank.
Present, sir.
Yashwant.
Present,
Yes, sir.
Present.
Pawan H. One more Yashwant.
Yes, sir.
Vinayak JH. Nitin GS.
Present, sir.
Shashank HS.
Present,
Pawan
sir.
TV.
Yes, sir.
Pawan H.
Present, sir.
Shamant. Rahul MP.
Present, sir.
Yashwant S.
Present, sir.
Swati DN.
Present, sir.
Pratik.
Yes, sir.
Vedavyas.
Present, sir.
Pritam D.
Present, sir.
Please